were just testing it out to make sure that students don't face any trouble while entering the details, right? So you go there and you put each of your team members' detail. Let's say Robert puts in his info and he gets two more other friends. So first Robert puts his info, his contact number, email, LinkedIn profile if he wants to share them. You can just uh, add. So what happens is that info gets added as a team over here. Like instead of Sid, you will see Robert, and then you add another team member. Let's say if you're a 3-member team, then you details of other team members as well. So this is required because we need the info of your friends as well. So their data is also important to be on the platform. So make sure two things. First is the team member who's registering the details for other team members has to make sure that the details of the team members is put in here, right? Second thing is if you know your team member is registering on your behalf, make sure you cross check with him that your details are mentioned here. Otherwise, you'll be lost in the data and we wouldn't find your data, which will be a problem during the database certification process. So make sure that that happens, right? Is okay. All right. So these are some critical things that you need to keep in mind while you are working here. Faiz Rahman Ji. Sir, if you can type your query, it would be great. You have raised your hand. All right. So guys, we'll start in a minute or two. Hang on tight. Today we also have the leaderboard of the quiz that happened yesterday. Some exciting names are going to be there, so make sure you're here. You don't miss out on all those names. It's quite exciting to see all the people who do good, and also you see that when the names come up, some of the names are may not come up like you would have expected yourself to be there, but you don't. But then next time you also have the opportunity to do that. So we have ample of quizzes during this entire technical session. So uh, don't sweat. I mean, you will have ample of opportunity to make it to the leaderboard if your name doesn't reflect. So keep up the hard work. It's just a gesture to show that if you keep on your hard work, it will be fruitious for you. And one another important thing that my friend Rajesh has suggested that you all should know is the email that you put while registering on events.ibc media dot media should be the email that you have used with while registering with IBC. I mean, in the normal Google form, or you have to use one mail to at all the places. Don't mix up your emails. So that is very important while you use multiple forms or registration processes because we're tracking a lot of things. So make sure that you use one email, one contact only. And also the name format that you put. Let's say somebody's email name is so for my let's say my name is Deepak Kumar Singh, right? So if I'm somewhere writing Deepak Singh, then somewhere I'm writing Deepak Kumar, and somewhere I'm writing Deepak K Singh, then I mean that's not the right way to go.
So can we start, Deepak?
Yes, Ashwin, we'll start.
Okay.
Just give me a moment. All right, guys, very good evening. We'll start with the session right away. And before we start with the session, we have the leaderboard for the quiz that you all have done yesterday. Requesting my team to requesting Deepak to just show the leaderboard with all of us. Yeah, can we start, please?
Yeah, let's play that, Deepak. Deepak, is any problem in this?
Okay, so Deepak, let me share the screen. I'll play the leaderboard. One sec. You can stop sharing. I'll share. Is the audio if is it audible?
No, Deepak, no.
Okay, let me just start it. Deepak, can you put off your screen, share, or you want to play it? One second, just give me a moment. Is it audible now?
No, Deepak, let's continue without the sound.
Yeah, so I think there's some glitch. Generally, it turns on, but let me just put on the leaderboard very quickly. I'll just cut to the leaderboard. So we have Lokeshwari S, who has topped the leaderboard, and he has scored. Uh, Sorry, I don't know if it's he or she, but first of all, congratulations for scoring 18 out of 20. That's brilliant. You have done so amazing in the first session, and that same goes for Gokul S, and also for all the students who are part of this leaderboard: Anova, Sherin, Nivedita, D. Dinesh, Surinder, Karthik, A. Shruti. But that's not all. We have more students. Okay, let me just come to that part very quickly. We have Bharat Kumar M and Srinivasan K, Nadiminti, Gautam, Vetrivel, Ashok Kumar, Meghna, Aarti. Guys, this is brilliant what you have achieved in the first session itself, 15 out of 20 to 18 out of 20. All of you, this is brilliant work. Kudos. And we wish to see a lot of new names. And at the same time, I hope all the people who are here in this leaderboard continue doing this incredible. Praveen sir, any words of encouragement you would want to share?
No, it's wonderful. I think it's a fantastic testimony of you focusing on the session and understanding the subject. So I think this journey has just started. You need to continue pushing, beyond the boundaries, and of course, let's make this competitive. I know many names here, and like Deepak mentioned, we would love to have more names coming into, new names coming into, and all of you defending your position, others trying to get into. I think let's make it fun, guys. I think that's how you learn, and we're trying to provide you that environment here, and all the very best to all of you. Thank you.
Absolutely, so thank you so much. So, guys, congratulations once again, and wishing everybody else to just work hard and come out on the leaderboard. Great work. Rishan, I would request you to begin the session. Once again, it's awesome to have you here. We had a great session last time, and I'm just waiting for another brilliant session from you. Thank you.
Thank you, Deepak. Thank you, Praveen sir and Deepak Chaudhary. So we will try to start the session right now. Is my audio as well as my video visible? Thank you.
Yes.
Okay, I will share my screen. So is my screen is visible, right?
Yes, Rishan.
Okay. Welcome everyone to the second session of Programming Rust. And before starting today's session, we will be discussing some of those questions in your previous day quiz, which we felt to discuss because it feels like an important questions to be discussed. Okay, so we discuss those questions. Wait 1 second. Okay, so we'll start with question number 2. Okay, question number 2. Yeah, question number 2 was, which of the following is false with respect to tuples? Okay, now reading the options, the first option says that tup is the keyword used to declare tuples. So in Rust, this tup is not the keyword used to declare tuples, but it is the keyword that we use in Python. Okay, so don't get mixed up with these keywords. So in Rust, we actually don't use tup. Okay. The second option is tuples have a fixed length. Okay. Tuples actually they don't have a fixed length. We can set the length for a tuple, but then it is immutable. So once set, you cannot change it at any point of time. The third option is tuple element can be accessed. No, it cannot be accessed by using dot. We need to index it. And then the last option is your right option. That is every element of a tuple must have same type. Okay. That was one of the important points or properties of tuples that I discussed yesterday. So that is the most important one, that every element of a tuple. So it is the wrong, it is, the question is, which is the false respect to tuples, right? So every element of a tuple must have same type is the wrong answer. Okay. Then now we will be discussing about the fourth question. And then the fourth question is, what is the output of this Rust program? Well, you are not actually asked to write which is the output of the program. You are asked to write any of these conditions. So the program exhibits undefined behavior, or the program does not compile, and the program is guaranteed to output, right? So this question has got the answer of the program is guaranteed to give you an output. Now, why is it? Because there is no syntax error or there is no semantic error. Okay. Now here you are using standard memory operations, and the std is then called, and then we are assigning a variable a equal to true. Now then we are trying to find its size, that is mem size of val, and we are passing the reference. Okay. Now here, if you try to run this code, obviously it will give you a result like 0. And this has got no syntax or semantic errors, and this is why the reason you will obviously get an output with this code. Okay. And then the next question of discussion will be question number 7. Okay. Here in this question, if you look carefully, this kind of an implementation is actually valid in C, because you can do operations using unary operations using C, but then it is not valid in Rust. And moreover, here you are trying to change the value of a constant, and it is actually impossible to change the value of a constant. And this is why the program does not compile. It is actually a compilation error. Okay. And then we will discuss question number 10. Question number 10 is one of the most important questions, which I think most of you should have got it wrong or sometimes maybe right. But then it is one of the questions that we need to discuss because it is a core concept level question. Among const and stat in Rust, which one has low memory requirement? The point you need to consider is that const is actually setting its value during compilation time. So it doesn't require runtime memory. But whereas static is actually substituting its value during runtime, and that is why it requires runtime memory. And obviously, this is the reason why const will have low memory requirement than static. Okay, that is our meaning. It is one of those important questions that you need to understand for the core concept of Rust. Now, then this is another question that most of them have got it wrong. What is cargo in Rust? Well, there are options which are confusing in this system. So if you see carefully, the answer is build system and package manager, because you can use cargo to build using cargo build and cargo run. So you can actually use it for both of these things. And also it acts as a package manager using the dependencies. So these both the options are right. And that is why you should go with the option number 8. Okay. Now, which company controls the Rust programming language is one of those. This is basically a GK level question. So the answer is Rust Foundation. The Rust Foundation actually takes in consideration of the programming as well as R&D of the Rust. Okay. Now, the next question of consideration is question number 13. Okay. Is Rust an object-oriented? No. So, well, it is multi-paradigm. So it can do object-oriented programming. It can do functional. It can do procedural. So it can do multiple things, and that is why we call it as a multi-paradigm language. Okay. Then we have question number 15. Then question number 15 is same to that of question number 10. So we will enter our discussion of the questions here, and then we will go with the session. Thing it is visible, right? Okay. So we'll start today's session, and today's session we will be discussing two important factors of Rust, and that is the ownership and borrowing. Okay. Now this is one of the core features of Rust that makes it unique from other languages like C or Python and any other consideration. And this is one of those important features that make Rust safe. Okay. So let's see what is ownership. So before reading this concept, I want you to imagine yourself owning a car. Okay, so let's say you are having a car, and then you are going to give this car to your friend. Okay, right now, at this moment, you own that car, right? And now when you sell it to your friend, you lose the ownership. Now your friend is the corresponding owner for your car. So it becomes her or his car right now. And that is the point of ownership. You can share or you can give ownership from one person to the other. And you can do it. And this process of sharing ownership or sending in ownership or giving off ownership is called as move in Rust. It's called as move. Okay. So as far as variables are concerned, first initially we will define a variable and we will substitute a value. And we can move that value to another variable, which is possible in Rust. But then the problem is once you move the value, then the initial owner now does not have any kind of value. But we will do some of the demonstrations as soon, and you will get into the concepts very fast. But then this is the whole concept that you need to put in your mind, that basically we can give ownership from one person to the other. Then obviously the initial guy will lose his ownership. Okay. So ownership is considered to be Rust one of the most unique feature, and also it enables Rust to imply memory safety. Yeah, so this session we will be discussing why Rust is called memory safe. Okay. And now in the last session, someone asked me a question regarding garbage collector. You know, Python uses garbage collector. So what is garbage collector? Garbage collector is an automatic memory manager that actually does the activity of freeing an allocation of memory for variables That means if I want to allocate some memory for my variables, then the garbage collector does that for me. So I don't have to take up a headache of doing the same. But in C or C++, you are actually advised, or you need to allocate as well as free the memory, okay, by yourself. And that is one of the reasons why C++ is not actually not memory safe. Okay, because you need to consider all those edge cases, which in turns become too tedious for any person or any software developer to look upon. Now, we will see into memory management. So in C++, as I have just mentioned before, a programmer must explicitly allocate and free the memory. Okay, this is actually done using functions like malloc and calloc. If you are into, so if you have learned C, then obviously you'll be knowing all these concepts that I'm trying to mention. If not, then just try to imagine allocating some memory or allocating our RAM to execute a particular program. Okay. Now, Python have garbage collection, and so we are not concerned about the allocation as well as freeing of memory as far as Python is concerned, because Python makes these things easy for you, and that is why Python is very easy to write and it's very easy to implement. But then the problem is it makes it slow. Okay, makes it slow. And also we cannot completely entirely give the memory management to a programming language then, or the compiler. Then the problem is we cannot try to implement the efficiency, and also sometimes there will be issues regarding pointers. So it is always advised, so we need to have some control over it. And this is a combination of both C++ and Python approach that we bring up into Rust. Okay, so in Rust, memory is managed through a system of ownership and borrowing. Okay, we'll discuss both of these things so fast. Now, before that, from the topic of our discussion till now, we are going to conduct a very small poll quiz. I would like everybody to pass this. And then before just starting the quiz, I want to say that you might have heard of string data type. Okay, so string data type actually passes ownership in such a way that once passed the ownership, you cannot actually get it back to the old variable. Now, I think you might be misconfusing with this term. So we will do it in the practice. And there are two kinds of variables, one which has copy trait and one which does not have copy trait. Okay, we will discuss it soon. Okay, before that, I will just start the poll. Please make sure you answer the questions. The time has started. You will be given 90 seconds to answer the question. Please make sure you're ready and then start answering. Okay, I think it's time to close the boards. So I'll share the results with you. Now, the first question, around 69% has got it right. So obviously, we will not be discussing that question. And the second question also, everyone has got it right. Today, 88%. Kudos, guys. I will go to the next point of discussion. Okay, I will just need to stop sharing this. Okay. Yeah. So now, before going into the string and those concepts, we will discuss about two things. And after this, I will be talking about the copyright implementation as well as in the case of string. What is stack and heap? So as far as the programming language is considered, we have two implementations in memory, which include stack and heap. Okay, so stack is actually an LIFO data structure. LIFO means last in, first out, in which you can store a particular kind of data type or data if you know its size at compile time. Make sure you hear it right. If you know its size at compile time, then you can add it into the stack. But if you don't know a particular data structure's size at its compile time, then you'd be knowing its size at the execution time. But then the problem is you can only keep that data structure in heap. Okay, you can only keep that. Now just keep these two terms in your mind. What is stack and what is heap? So if you know the size, you'll place it in stack. If you don't know the size, then you'll place it in heap. Okay. And there are two operations with the stack, and that is push and pop. So this comes under the data structure session. That is basically, it is like a set of plates. What you can do is you can place a plate over another and then you can stack it up. Now, if you need to take a plate out, then what you will do is you will take a plate from the top, right? So the first plate you kept should be at the bottom and the last plate that you kept should be at the top. Okay. So when you're taking out plates, obviously the top one will be removed first. Okay. That's the whole concept of stack. Heap is basically a memory allocation system where you actually do not have to know the size at the time of instantiation. So heap actually works with the memory allocator and it finds an empty spot in the heap that is big enough and it turns out a pointer at the time of memory allocation. Okay. Now good examples will be I32 is a kind of stack implementation. Now why is that? Because if you are using I32, you actually know that you are going to type in a value of integer which is signed and is of 32 bits. So you actually know the size, what is required for I32. So it is actually kept in the stack. But whereas in case of vectors or hash maps or strings, which can grow during the course time, you need to keep them in heap. Okay. So I think you will get the concept of stack and heap. And if you have any doubts, feel free to ask it in the Q&A. We will so resolve it. And in the implementations, I will try to explain it more. Okay. Before that, we would like to go into another question. And I want you to remember that string is actually placed in heap because it is a growing one. And those things that are placed in stack has got its copy trait implemented. But in the same, those things which has got its copy trait not implemented will be placed in heap. Okay, just remember these points and now get ready for your second poll. I'll be giving you 90 seconds again. Make sure you try to do it as fast as possible. It's time to close the poll so you can answer as fast as possible. Yeah, we are coming to the end. So I'm sharing you the results. The first question, yeah, most of them has got it right. It's 82% right answer. And the second question, yeah, 64% has got it wrong. So obviously, we'll discuss why is this. And the copy trait, as I said before, those things which are placed in the stack has got the copy trait implemented, but string is kept in heap, and that is why it has got its copy trait not implemented. Okay, so the answer was false. Now we will, you don't have to worry about this right now. Okay, we will discuss it in a more depth session right now. So we will discuss it as soon as possible. So you don't have to worry about these results. Okay, and we'll continue. So before going into ownership, we'll discuss what is ownership rules. Okay, so there are 3 simple rules for ownership, and that is each value in Rust has got an owner. Okay, so every value or every variable that you create or any value that you set should always contain a owner. Okay, and there can only be one owner at a time. And when an owner goes out of scope, the value will be dropped. That means if you are going to define a variable inside a particular block of code, then once we get out of that block, this particular variable is dropped. Okay, so its lifetime or its scope is only limited with that block. Okay, now I will show some examples later. Now if you see, this is going to make your understanding regarding the scope very easy. So please pull out your attention for a moment. Now consider the variable inside the block. So this is a block with the constructors, and then I'm going to write let x equal to 25. Okay, now you can see let x equal to 25 only lives within this constructor, right? So that block of code is the place what we call as the scope of the variable x. Okay, so out of this block you cannot access this x, right? So out of this scope you cannot access this x, and that is why we call the inside the block as the scope of the variable x. Okay, and when x comes into the scope, it becomes valid, and it is valid until it goes out of the scope, and that is called as lifetime. Okay, we will not be discussing a lot about lifetime right now, but then we will be discussing about the scope. Now string. So as I mentioned before, string is actually a combination of characters. So if I'm going to write my name, then it will be written in string. So if you see hello world is actually a string. Yesterday we tried to print hello world into the screen on the terminal. It was also a string. Okay, so hello world is a string. Now string is a type that is stored in heap. Okay, so we need to know its size at compile time. This is a must, right? No, we need not have to know its size at a compile time. That means, for example, if I am going to ask you to type in a string, like for example, I'm going to ask you to write your name in the program, and you are going to write a name with different lengths. So each one of you will have different names and of different lengths. Now, I do not know its size at the compile time. Okay, so I am only going to know its size at the execution time. And this is why we keep it at the heap, because heap allows us to have a lot of memory into consideration. Okay, so any growing data structure will be kept in heap. And this string can be mutated, whereas string literals as they can be. And now we will talk about the 2 different kinds of strings in our session 4. And we will not be discussing much about the strings right now, but just know that this is a string, and this is how we set a variable with string. So let x equal to string from hello world. Okay, I'll show a small demo how to do that. See, inside the, okay, I will just zoom in. Okay, inside, if I'm going to type let x equal to string from hello world. Okay, now what happens is that this x is actually given as string. Okay, and that string is actually present inside this, and this is called as a string in Rust. But then we also have another implementation of string called as and_str, which we will not be discussing in this session, but on the later sessions we'll be discussing what this is. Now you can print a string by just typing in println, and then place the constructor and space X, then just cargo run. That would be an easy thing. Okay. Cargo run. And this will print the string to your terminal. Okay, this is how you use strings. Okay, but then as far as concerned, initially at the compile time you don't know X, right? You'll be knowing X type at X size at execution time. Okay. Okay. Now we'll go to the other concept, that is memory allocation in strings. So as I said before, strings are mutable. So strings are mutable. That means even after instantiation or even after giving it a particular value, I can change it to another value. So like hello world can be added upon with some other strings after. Okay. And we will discuss more about the strings in later sessions. But then I just want you to know that a string can grow. Okay. That is the whole concept. And the memory requested from the memory is allocated at runtime. Okay. And then we need a way of returning this memory allocator to those strings. So this PPT might seem a bit long because I wanted to import all these contents to you. So that is why this PPT looks a bit long. Then the concept is actually easy. I'll try to explain as easy as possible. Okay. Now we will see how we will allocate memory. So it's basically this is the concept that the compiler uses to actually allocate a space for string. So what it does is basically when a string comes into our scope, then we will by default give some space. Then if the size exceeds, then obviously we will be giving more on spaces. Okay, it's like a vector. So string is like a vector. Now we haven't discussed vector. So obviously vector is let me say you know what is an array, right? Yesterday we discussed what is an array. So initially we will set a size of like say 4, and obviously the size of the data increases by like initially you have got 4 characters in your string, and now I'm going to add one more character. So obviously I do not have the space to put the 5th character, right? So what I will do is I will take another memory space and then allocate a size of 8. So we will double it. Okay. So now I will have a size of 8. Now I can put my 5th character to this corresponding newly set memory, right? This is a similar implementation that we use in strings as well. Okay, so strings is similar to vector, except that we use the direct character, and then we have another operations defined into strings. Okay. And one of the important consideration topic that we will discuss here is called as the drop function. So once we go out of the scope of a particular variable, the function that the compiler would call is called as a drop function. Okay, so the drop function is called once we go out of the scope. Okay, I will also show you an example of what is a scope. So you see, I'm going to put a constructor here, and then I'm going to type let my x is equal to 2. Okay, now try accessing it from the outside. Print ln x. So obviously it is not possible. You can see an error here, that is cannot find x in the scope, as it is not found in the scope, because x is only set inside this scope or this block. You can only access it inside that block. We have discussed a similar concept in yesterday's shadowing topic. Okay. So this is the overall idea about scope. You don't have to get confused about scope. This is the idea. Okay. And this x can only live inside this block. This is the whole concept. And now we will go to the discussion again. So that is all about the memory allocation in strings. Now, with the all concept that we have discussed right now, I want you to remember the main concepts like drop function and then the string. Okay. So this concept, I think it should take some time for you to understand, but then try to use your intelligence to answer these questions as fast as possible. I'm going to launch the third quiz. You'll be having 90 seconds to answer these questions. These are pretty much easy questions that you can do it. Okay, I guess the time's up. So we will close the board. And I will share this. So the first question, the answer is drop, and yeah, most of them has got it right. Nice. And the second question, we have which out of which of the following is immutable by default? And the answer is and str. So we have not discussed about and str, but then obviously you could see the options, the three options, and vector as well as array and then string are all mutable. Then and str is actually a pointer, and that is why it is immutable by default. Okay. As I said before, string is mutable, vec is also mutable, and then array is also mutable. Array was discussed yesterday, and today we have discussed vec as well. So obviously these things are mutable. But then and str is one of those options, which is an odd one out. So obviously this is the thing that is immutable by default. Now we will discuss why in the later session, or else obviously because and str actually returns a pointer. Okay, it is actually a reference. So as it is a reference, you are not supposed to mute it. Okay. I think you get the concept. Now we will go to the next topic. So variables and data interaction with move. Okay, now from this slide onwards, you will see the direct implementation of what I was trying to convey and how is ownership shared between different variables. Okay, so if you see, initially I have given the value 5's ownership to X, right? And then I have passed my value of X to Y. So currently the owner of 5 is actually Y. Okay, currently the owner of 5 is actually Y. So you can probably guess what he's doing. So bind value 5 to X and then make a copy of the value in X and bind it to Y. That is what we do. Okay. And as this is integers, obviously the copy trait is implemented for integers. So let me show you one implementation. Please bear with me. And yeah, let X, I think you can see my screen. Let X equal to 5. Okay. Then I'm going to type let Y equal to X. So what happens? Obviously, this X has got a value 5 and this value is passed to Y. But then I'm going to type println X, and then println Y. So as you do not have to confuse, Y is and then X is. Okay. Now we will execute and see what happens here. Take some time to run. Yeah. So X is 5 and Y is 5. Okay. So we pass this 5 to X and then we have also passed this 5 to Y. So now Y has got the value 5 and obviously X has also got 5. But if we try to do the similar implementation with string, let me say like let X equal to string from hello world. Okay, and then I'm going to pass this value to let Y equal to X. Okay, now I'm going to do println Y is okay. Now we'll do the same thing, that is Y is this and then X is this. Now you can see an error, that is borrow of moved value X. Okay. Now we'll see what is the compiler have to say. Look at this. So it says that value borrowed here after move. That means I have passed this string to X and then I have sent this value, that is the string from hello world 6 ownership to Y. So initially X was the owner of the string hello world. Okay. Then I am passing that to Y. So now Y is the owner of the string hello world. Okay. Now what's the problem then? Obviously X does not have any value right now. So you cannot print anything, because then X actually points to nothing. Okay, because now Y is the owner of the string. So X is dropped as soon as it sends its ownership to Y. Now this is possible with string because string is not a copy traded variable. Okay, so we have not implemented the copy trade for string, and that is one of the reason why actually this problem exists. Now this is good because we are transferring ownerships. Now X does not have the ownership to the string hello world, but then Y is the current owner of the string. Okay, that is why if I comment out this, then obviously you can have a clear code that will execute without any problem. Okay. So this was the example that I was talking about before. That is with move. That means when we move value of S1 to S2, then this will generate an error because the value can be accessed after move. Okay. That is the important thing. Because now internally what happens is that we only pass the stack contents of S1 to S2 and never copy the heap contents. That means what is the stack contents? So even for string or for any kind of data type, we have a stack content, and the stack content for string is basically what is its size and then its pointer. So we have a pointer to the heap from the stack. Okay. So we do not have the string in the heap, but then we have a pointer to the string in the stack. So what happens is that we will have this pointer to the heap. Now it is somewhat hard to imagine, but then this is the entire concept. So what happens is that we will have this X, okay, this X will contain the string hello world, and then initially the X components that will be holded in the stack will be its size, and then a pointer to this hello world, which is actually stored in the memory. Okay, and it is actually stored in the heap. Okay. Now, then what happens is that it actually transfers this pointer as well as the size of the string to Y. Now, what happens is that Y knows exactly where this hello world is placed in the memory. Okay, and Y also has got a pointer to the beginning of this string. So now what happens is that Y can access this hello world from the same place it has been stored in the memory. But then now only Y can access it because X has passed this to Y. No, X cannot do the same. This is the topic called as move. And what happens is that we are sending in ownership from one person to the other, from one variable to the other using the property called move. This is only applicable for string till now. Okay, we'll see what other data structures do have this problem. Actually, not a problem; it's a feature. But then people who are coming from a different programming languages, obviously this is actually not implied in other languages. So whether you take a string from particular variable to another variable, then obviously you can access the string from both the variables. So if I do this similar approach in Python or in C++, obviously I can get it from both. Now, why is Rust doing such a thing? Because it saves a lot of space. If I am going to pass the same value of hello or hello world to S2, then I need to copy the entire heap contents or the entire memory contents to S2, which also takes time, and moreover it requires me to keep another clone copy. All right, clone copy, or else I need to take the pointer and then both the pointer needs to point to the same hello world point, right? So any of these can be done. There are multiple implementations in different languages. Okay, so this is the most fastest way that you can actually move the values. Now this is called as a stack copy or a shallow copy. Okay, we'll discuss about this. And what is shallow copy and then is deep copy. Okay, so the concept of copying the pointer, the length and the capacity, that is what I just mentioned before, without copying the data is called as a shallow copy. So what we do is we only copy the stack contents. We do not copy the heap contents. Okay, stack contents will contain all these referred points, that is a pointer, length and capacity. And the heap will contain the real data in memory. Okay, now what Rust does it invalidates the first variable instead of being called a shadow copy. Now you need to remember one important point, that is Rust never automatically creates deep copies of our data. Okay, it never. If we need to do it, And we can do it explicitly by using clone function. We will discuss clone in a while. Then all you need to keep in mind is that Rust never automatically create deep copies of our data. What we do is we just take the shallow copy. Okay, so the data is actually placed in the memory and we only copy the stack contents. Okay, that is what we do in case of a move. So automatic copying can be assumed to be inexpensive in terms of runtime performance. So we do not require much time in copying the heap contents. Now it takes much time to copy the heap contents from one place to another, or setting the value from one variable to another and then resetting the pointers. It takes much more time. But obviously copying the stack contents is the fastest way. And I want you to recognize that point because it is important. Rust will never automatically create a deep copy, and then any kind of automatic copying that you can do will be considered inexpensive in terms of runtime performance. Okay. With that, we are ready to attend one more quiz, and I want you to get ready, and we will be given 90 seconds to answer the next question. Shallow copy and deep copy. Yeah. You can start answering. You'll be given 90 seconds. It's time to close the poll, and yes, I'll share the results with you. So the first question's answer is false because, and 55% has got it right. So Rust creates a deep copy of our data automatically. It is, as I said to you, that Rust never creates a deep copy of our data. What it does is create a shallow copy. Okay. And the second question is most of them has answered it right. It's 59% has got it right. The question is automatic copying in Rust is inexpensive. So it is true. It is inexpensive. Okay. Because we do not take deep copies, and one of you have answered. One of you have given me questions. What do you mean by deep copies? What kind of data deep copies have? So a deep copy means to copy the entire contents of the data that you store in the heap. Okay. And then you need to take a copy of the entire data and then pass it to the next one. Okay. So me not attended the quiz. Oh, okay. It's not a problem. You can attend the next quiz. Okay, don't worry. We will go with the concept. Now this is where we will talk about clone. And what does clone say is that if we want to deeply copy something, so it is not like we can always copy the stack contents. Sometimes we need to copy the entire value to the particular S2. Okay. So if we do not want to deeply copy, if we do want to deeply copy, then what we do is heap data of the string. It is not just a stack data. Okay. So what we use is we use clone. Now what you do is initially you will set let s1 equal to string from hello and then let s2 equal to s1 dot clone. Okay. Now you can print both of these because heap data gets copied. Okay. Now we will see that example so that you will get a deep understanding. So initially what I'm going to use is let x equal to string from say hello and then let y equal to x dot plot. Okay. Now we will print ln x is and y is. We will come with here and then x and y. Okay. I will execute this one. So x is hello and y is hello. So the last time we had a problem because then we moved this value, right? Because we moved the contents of x to y. But then why do we have like x is hello and y is hello this time? Because we use the clone function. As we use the clone function, the entire data in the heap is cloned and then is passed into y. So obviously what is the point is that now both x and y has got different copies of the same string hello. Okay, so both of them can be used to access it. So now what we do is not sending any ownership. What we have is like we have two copies of the same thing, that is cloning. Okay. Now what is copy trait? I have just said about copy trait before. Then and this is a special, though we will discuss traits in later sessions, but then try to cope up and try to understand. We try to explain. So Rust has a special annotation called copy trait. Okay, and this is one of those things that determines what needs to be placed in the stack and what needs to be placed in the heap. Okay, so if a type implements the copy trait, that means variables that use it do not move but rather are trivially copied. So what happens is that making them still valid after assignment to another variable. Okay. And as general rule, any group of simple scalar values can implement copy, and nothing that requires allocation or is sum of results can implement. That means you just need to consider all these simple scalar data types like I32, U32, floats, and then characters, all these things. These things have got copy trait implemented, and then what you can do is basically you can and just do shallow copies. Okay. So even if you send or even if you move these things, you can still access it from the same. I think I just showed you an example with the integers while we said x equal to 5, and then we also said y equal to 5, right? But then you could access both x and y at the same time without having any kind of problems. Okay, because copy trait was implemented. But in case of string, it is not possible. Once you move the value of x to y, you cannot access the string from x. But in case of integers, it is possible. But in case of float, it is possible. Okay, so simple scalars, it is possible. But then for other data types like string, it is not possible. For integer, it is possible, but then for string, it is not possible. Okay. What is ownership and function? So now we saw moving a particular value between two variables, right? What about me sending this value into a function? Okay. If I send a particular value to a function, then the ownership goes to the function. Okay. Now, if you do not return that value to the main function, then what happens is that the variable will die in this called function. That means, please take your attention to this given example. Here, I'm going to create a string called s with string hello, and then I'm going to pass like a function called take ownership, and then I'm going to pass this s to my function. Okay. Now what happened is s value is moved into the function. Okay. Now it is no longer valid after this because we have not returned anything. Okay, what happens is that I am creating this s and I'm passing this s into the takes ownership function. Okay, now that I'm not returning anything, what happens is that the string is passed into the function and the string will die inside the function once the function has completed his execution. Okay, so you cannot access this string outside this function. Okay, so what happens is that the whole concept is clear. Now we will do a simple implementation to make sure that you got the idea. So let me say that let x equal to string from high. Okay, string from high. Then I'm going to create a function. Let me function read string, which takes a string as input. Okay, and it does not return anything. Okay, what it does is it println s is, and then s. So what does this do? Now this function will read a string. That means it can take a parameter as a string and then it will print it. It does not return anything. Okay. What we do is we will call this read string here. Read string. And then we will pass x to here. Okay. Now we're trying to print ln after we move the value. So x is, yeah. So now we pass this value of x to this function, and this function takes the string and then it prints the contents. Okay. It does not return the string back to the main function. So what happens is that after reading this string at this point or at this moment, we cannot access it at here. Okay. Borrow of moved value x, because value is borrowed here after move. That means as x is not returned to the main function. But then we can solve this issue by returning a string. Returning a string, and what we will return is s. So we will return s. So what happens is that this function right now takes this and then it returns this. But then the problem is we require some variable to pass this value. So let's y equal to read string x. Okay. Now what happens is that you have returned that value to y. But if you want to print x and you need to get it back to x, then what you need to do is you have to come here, type it mute, and then change this y to x. So now what happens is that initially we had high in x, we passed it to the read string. The read string returned that string back, and as the x was a mutable variable, now it has overwritten its value, and now we have the high back to the x. Now when you are printing x here, what happens is that you can print x right now. Okay. If you have any doubts, please feel free to ask in the Q&A section, because these concepts are a bit confusing, I know it, but then with enough practice, you will get an idea of how this thing works. Basically, what happens is that we will pass this string to this variable, and this variable is passed into the function, and then we return that variable back to this main function by using the return operation, and then it is returned back to the same variable from which it has been sent. Okay, and we can now print. But if we do not return, we cannot print. Okay, that's our concept. I'm continuously saying the same concept because this is something which is literally new to most of you. So try to get the point. Okay.
Addition.
Yes.
Your terminal was not visible. Can you show us again?
Oh, my terminal was not visible. Okay, wait. 1 second. Okay. Thank you for mentioning that out. Okay, I'll just show the execution again. So you can see the output right now, right?
Yeah.
So
Yes.
S is high and X is high. Okay. And this is now what happens is that for both S and X, you can have this. And that's your concept. So I guess it's clear. We'll go to the continuation. Yeah, but then now I have shown you an example with string, which I said multiple times before that string does not imply copy tree. Okay, but with I32, you don't have such a problem. So even if you pass this X, look at the second downward example, okay, like X equal to 5. What happens is that if you pass this X to a function, still you can get this X in the main function, because this I32 has implied its copy trait. So once these things have copy trait, so basically you can access them even if you pass it into a function and never return it back to the main function. Okay. But for string, it is not the same case. Return value and scope, this is something that we discussed right now. That is, if you return it back to the main function, then the main function still becomes the owner of the passed string. Okay. Next time for us to have another quiz regarding all these concepts that we have discussed till now. And yeah, make sure you answer fast and steady. You will be given 90 seconds. Take your time and then read the questions and answer. Yeah, time has come to an end. Yes. I'll share you the results. So the first question's answer is true, and ownership of a variable is passed to a function when we pass the variable into the function. So most of you have got it right, and kudos. Now in the second question, yeah, most of you have a doubt in this section. Now, which is the trait that is implemented for types that are placed in stack? So what are those types that are placed in the stack? Those which we know the size at compile time, and this includes stuff like I32 and F64, but it does not include strings, right? So you do not have to implement the clone trait for these things. What you need to implement is the copy trait, and copy trait is already implemented for these kind of I32, F64, and all these concepts. Okay, so those things are which it is placed in the stack, and this is why we can even access them after passing it to a function. Okay, I think it's clear for you right now, and I will stop sharing, and we'll be describing some of the questions that are being given in the Q&A. Okay, even if we use clone function, can we copy the string? Well, you can't copy the string without taking the clone function. No, you cannot. Because what happens is that you are doing a shallow copy. So in shallow copy, you are actually not copying the entire string. What you do is you do the you're just taking the stack contents. Okay. So at this moment you cannot copy it. But then there is another way of doing the same thing, that is to take a reference, and that is borrowing. We'll discuss that in a short time, so you don't have to worry. But basically right now what we do is we take a total deep copy and then pass it to the next variable. Okay. Does clone work on string? Yeah, yes, clone works on string. That is a similar example was shown in the implementation. So it is a little confusing. Okay, if you make sure what is a bit confusing, then we can just solve it. So cannot see the quiz. I was sharing the quiz right now. Yeah. Okay, then. I think we have addressed all these questions. Okay, you want me to show the results again? Okay. Is it visible right now, the answers? Please make sure it is visible for you right now, the answers. Okay, thank you. Okay, now I'm going to stop sharing the answers, okay, and we will go with the concept. And please do ask any kind of doubts in the Q&A. We'll try to resolve it as soon as possible. Yeah. So the next topic is references and borrowing. So one of my friends have asked a question regarding the copy without clone, right? So you do not have to take a copy if you have a reference. Okay, we'll discuss how it is possible using reference. Now, reference is the whole concept of borrowing. It is simple as like you borrow a pen from your friend to just complete your notes, and then you give that pen back to your friend. So you are not the owner of the pen. but you are just the borrower of the pen. Now, if you see that in our normal Indian rupee notes, you can see that you are a borrower of each currency and you are not the owner of the currency. Okay, so it means that you are not the entire proprietary owner, but then you have just borrowed it for some time and then you are going to return it in the future. Okay, so reference is like a pointer. It's just an address. So it can follow to access the data which is stored in the heap. Okay, that's it. Now what happens is that, look at the example given. So let S is equal to a string from hello world, and then let X equal to read string and S. And we have the read string to be S and string, and then println S. So if you see the next PT, so there is no implementation in the next PPT. So yeah. Now in this case, this would not give you an error even if you try to print S here, because you only pass a reference. Okay. So you once you say, so I want you to be very much attentive right now because it is important. So once you set S equal to string from hello world and you are passing a reference of S into X. Okay. Okay. You're passing a reference of S into the function read string, and then it is returned, whatever is to be returned, it will be returned to X. So the point is, we are not giving the entire ownership of S to X. We will see an example to clear such kind of doubt. So basically what we will do is, here, rather than passing the string itself, I'll be passing and X, and here I will be giving and string. Okay. So you need to return and I think this will be a good implementation, but then what happens is that you are passing the reference. Okay, you're passing the reference. So as you pass the reference, the ownership is not passed to this side, and hence what happens is that you can still access it without returning. So what I will do is I will just delete this and then I'll delete this. Okay, so now it is passed, and then you have this and str. Then the problem is let X equal to, I don't have to take this thing. Now what happens? Yeah, if you see the code right now, it doesn't show any kind of red color. What does that mean? That your code is valid. So what is the difference with the previous section? Now you have this high and you passed it to X. So now X is the owner of high. Okay, but then I'm going to pass a reference of X. This and X means you are taking a reference. That means you are borrowing the X. So you are borrowing the X to the main function, to the read string function. And then you're doing some kind of activity here, which doesn't matter. But then you still have got the X ownership at the main function. So you have not passed the ownership of X to the read string function. It is still within the main function. Okay. So the ownership of X is present here. And then you have not passed the ownership, rather you have given a reference to the read string function. And hence what happened here is that read string has taken a borrow of X. Okay. It will return it back, obviously. The problem is it does not have to return. Then the copy or the X is still inside this main function, and that is why it is possible for us to print X even if we have passed the reference of X to read string function. Okay. So when I run the cargo run, you can see that take some time. So S is high and then X is high. That means I can still access the X, right? Even without returning anything, I can still access the X. So that is what happens if you are not passing your ownership. Rather, you take a borrow. Okay. It's our concept. So I think it's clear, but then it is obviously a new concept. And this thing with an ampersand is called as a reference. And ampersand X means what you are sharing here is the pointer to X. Okay, it's a pointer to X and not the X itself. So obviously, what happens is that in memory, you'll be storing this high at some location, and then you will have a pointer to this location, right? you'll have a pointer. Pointer is basically the address. My friend, what happens is that when the mailbox, and mails are sent to you, obviously what happens is that they come to your address and then they'll give you the mail, right? In a similar way, what is here, we have an index means it is the pointer. Pointer means it is the address. It is a reference. Okay. So it is the address of X that is being passed to the read string. Now the read string can access the S by going to that location. Okay. But still X lives within this main function. And that is why we are able to get the value of X by using this println function in the main function. Okay, I've repeated it multiple times. I think it's clear. Not, then please feel free to ask in the Q&A. Is this quiz valid? I don't think, but you can ask it with Deepak. Okay. So references and borrowing, we have discussed this concept. Now you will see what is references and borrowing continuation. So the ampersand represent references and they allow you to refer to some value without taking the ownership of it. And this step is called as borrowing. Because we do not own it, the value it points to will not be dropped, because when the reference stops being used, that means we are not owning it. What we do is we are taking the borrow, and that is what happens with when you pass and X. So when you pass and X to a function, you are not owning it, but you are borrowing it. Okay. Just as variables are immutable, so as references. So initially references are immutable. So how to mutate a reference? That is one point of discussion where we do is and mute X. So what happens is if you pass and mute X, then what happens is you can actually change the value. So this is one thing that you will do with the data type setting when we are working with references. Okay. So we are not allowed to modify a reference initially by default, but then if you have mutex and mutex, then obviously you can change the reference. Now, what is a mutable reference? So see this example. Let mutex equal to string from hello world. Okay. Now we are passing it into a change function called change and mute s. So now we have passed and mute s. What does this mean? So you are passing a mutable reference. That means this reference can be used to change the value of s. Okay. So if you are doing the same with and s, then it is not possible. But then with and mute s, it allows you to change s. But if you are even passing and mute s, that means the s should be mutatable. Okay, they should be mutable by initial. That means this is why we are setting the s to be mutable. Okay, so if you just write let s equal to string, and then you are trying to pass a mutable reference to it without making the variable mutable, and obviously it is an entirely wrong concept. Okay, so it will give you a compilation error. Now you need to make the s mutable, and then you can pass a mutable reference of s to this function. So what happens is borrowing again. Now this function takes this value s and mute string, and then s dot push str. Now s dot push str means add this another string which is being given inside the push str function with the current string. So what we will return is hello world, hi everyone. Okay, so hello world, and then this hi everyone is concatenated. Okay, hello world, hi everyone. That is what is happening in the scene. So mutable reference is passed, and hence the value can be changed using the reference. Okay, so if you pass a mutable reference, you can use that mutable reference to change the values of the variable. Okay. This push str function is actually used to concatenate multiple strings. Okay. We will discuss about the push str in later sections when we will be talking about the strings. Now this is mutable reference. The entire concept, like, can just keep on doing this, but then I would suggest you to follow the concept and then do more practice with the mutable references. Mutable references can be used to change the value that they hold. Okay. And there are more concepts regarding what is the benefit of having a mutable reference and what are the behavior of mutable references. So the first benefit of having a mutable reference is you can then pass a reference and then change the value corresponding to the reference. And then there are some rules, that is data raise or raise condition might happen if you use like it can be prevented, and sometimes it may occur also. So we need to be sure that how we use pointers. Now, pointers are some of the very useful things, as well as it has got a lot of disadvantages. So when you're using pointers, you need to be very careful. And 2 or more pointers shouldn't access the same data at the same time. Okay. And at least one of the pointer being used shouldn't be to write data. So these are the concepts how we will like, if you have learned Java, then obviously you'll be knowing like how we will synchronize 2 different pointers. So if you do not synchronize, then what happens is that let me take an example of writing and reading into a file. So you have 2 pointers, and one pointer is actually pointing to the file, and we are going to write into that file, and another pointer is actually pointing to that file itself, and we are going to read from that file. Okay. Now, if you do these things simultaneously, then obviously we will get abrupt results, right? And that is the concept of synchronization, where we will first allow to do first a particular thing, and then we'll be doing the next thing. Okay, that is synchronization. Synchronization is a very important concept. We want to discuss about synchronization, what is async, sync, and all these concepts. Okay. Now it's time for another question. Make sure you had those concepts regarding and mute s and s, and then passing s to functions. Okay, I believe you will do much better in the case. I'm going to launch the second last quiz right now. Yeah, you'll have 90 seconds. Please feel free to ask as fast as possible. So it's time to end the polls, and we'll see the right answers. So the first question, yeah, 79% of you have got it right. Yeah, it's the right answer. That is to have an ampersand symbol. And the next one, 54% of, so we will discuss this. We can have a mutable reference while we have an immutable one to the same. No. So it is false. Why? Because if you have a mutable reference, okay, while you have an immutable one, that means you have a immutable reference that is pointing to a particular string or particular value, and then you have a mutable reference that allows you to edit the value. Okay, so let me say you are pointing to particular value, and then you have a mutable reference that will allow you to edit the value. It is not possible, because once you edit the value, then what is this immutable reference pointing to? Okay, so that is the problem. So we can have a mutable reference while we have an immutable one to the same value. It is a false statement. Okay, so we cannot have such a scenario. That means we are doing some memory errors. Okay. There any Q&A? Now open questions. Okay. So now we will come to one of the more important discussion topics called as dangling references or dangling pointers. This has been one of the major problems present in C or C++. That is a pointer pointing to nothing. Okay. So the problem actually occurs when you are setting a pointer to some kind of value, and then you free that value. But then the pointer is pointing to something. It is pointing to none. Okay. Or null. So a pointer that references a location in memory that may have been given to someone else by freeing some memory while preserving a pointer to that memory. That means you are pointing to something which has already moved or which has already been freed. Now you are actually pointing to nothing. Okay, that is called as a dangling reference. This is one of the major memory errors. So in Rust, what happens is that references will never be dangling references, because we have some of these rules that you need to consider. At any given time, you can have either one mutable reference or any number of immutable reference. Okay, so at a given time, you can only have either one mutable reference or any number of them. That means if you are having a mutable reference, then you cannot have an immutable reference together with it, because you are pointing to something which is immutable. Okay, then you are going to mutate it by using another pointer, which is not allowed, because that means you are going to change the value. Let me say the old concept. Okay, now you are having a immutable reference to a string, say hi. Okay, now initially we have got some memory for this high, and we are actually setting this high with two values, like two characters into the memory. And you are having another mutable reference, and you're going to change this high to hello world. Okay, now what happens is that I just explained the concept of vectors before. So what happens is that now the size is 2, but then after changing the value to hello world, what happens is that your size has increased. Now, sometimes in memory, you do not have this continuous set of memory. Okay, what it does is it deallocates this memory and finds a new memory, and it then copies this data to this location, and then adds and actually updates or anything is done on the new memory. Now, if you have an immutable reference, then it is still pointing to this old memory, but your mutable reference has already changed this value and then pasted this contents to a new memory. Okay, so that is why we say that if you have a mutable reference, then you cannot have multiple immutable references. Okay, and references must always be valid. Then there is another point, that means if you are actually having a reference to something, then you need to drop that reference first, then only you can drop the value. Let me say it again. That means if you are having a string s and then you are having a pointer and s, then initially you need to actually drop the and s, because it is a pointer to s, and then only you can drop the s. Because if you do otherwise, then what happens is that and s will be pointing to something called as null. Okay, so if you have a reference and a value, then initially we will be dropping the reference, or else we will have memory errors. And Rust prevents all these errors by considering all these cases in foresight. Okay. Now, let me show you some examples. So if and main, what you do is let reference to nothing is dangle, you're calling a function. That's it. Now this function is actually going to return you an and string. And string means a reference to a string. And let s, so it creates a string inside, and then it returns this and s. So if you are just going to write and s, which is the last statement of a function, then you are going to return. So what happens is a dangling pointer. So and s is a dangling pointer, as it tries to return pointer to a value which will be dropped as soon as the function. So what happens? So when you call the let reference to nothing equal to dangle, so when you call this dangle function, it creates a string and then it tries to return its pointer. But the problem is the string only lives inside this function, right? As I said to you before, that you are only supposed to drop the reference first and then the value. So it is trying to return a pointer to some value that is actually dropped after the function has been executed. So now this will give you some kind of error. Why? Because you will be trying to have a pointer and s which do not point to anything, because the function has been executed. So if you want to get the and s, like let reference to nothing equal to dangle, if you want to get this and s, then obviously you need to execute this function. And as soon as you execute this function, this s is dropped. Okay, because it goes out of scope and this s is dropped. Now what does this and s point to? Doesn't point to anything, right? So this is invalid. Okay, this is invalid. So this problem can be solved by just returning the string rather than returning the pointer to string. So if you return the string itself, then the string can actually have the ownership being passed rather than the reference or the borrow being passed. So we will need to pass the ownership. Rather than just returning and is, we would suggest to return the string itself. So if you create a string inside the function and you want this string to be in your main function, then return the string rather than returning the pointer to the string, because the string that you create inside a function only lives inside that function, and it is pointer can actually take the string outside the main function. But these kind of stuff can be applicable in many other languages, but Rust actually doesn't allow you to do it because it wants to be as safe as possible. Now, what is a slice? So slice is actually a part of the string. Okay, a part of a reference or a contiguous sequence of elements. So you can have it for string, you can have it for array, you can have it for vector. So what is a slice then? So let's just consider a list of 1, 2, 3, 4, 5, 6. Then 2, 3, 4 is actually a slice from the corresponding list that I have mentioned. So if you have a large, like it's like referring to substrings. Okay, so if you have a large string, you can have a substring. The substring is always a slice. It means you can have some sequence in between the larger sequence. Okay. Now, what you need to understand is that slice is a reference. It does not have ownership. Okay, it does not have ownership. What it does is a reference. And slice type reference is used when we have to return indexes of strings which are cleared without clearing the return index. Now, when we learn more about strings, we will let you know that strings can have indexes in Rust, but then we can have slices in Rust, but then we do not have indexes. Okay. And that will be of later discussion, but then try to understand that slice only got reference. Okay. So here we would rather return the reference to the slice rather than the index. So indexing is not possible for strings in Rust. What we do is we will try to return the slice. And that is your concept. So an example will solve most of your doubts. See that we are going to pass an and string to this function first word, and this returns an and str. So let this bytes. Okay, why are we using bytes? So we are using bytes to convert this entire string, which is in character, to bytes. So it is easier for us to enumerate and then iterate through it. So we have a loop with for I and item in bytes, and so this is enumerate and iterator, which is some concept that you will require some time to understand. And I'm not going to explain it like you don't know these two functions. It includes two functions like iterator, and then enumerate. So enumerate means list out all these characters and its corresponding bytes, and then we are iterating. So just think like we are going to iterate through the string. Okay. If we have a string hello world, then we are going to iterate through HELL. Okay, that's our concept. You just put it in mind. So if item is equal to this, that means space B space. So like B colon, that means if item is equal to space, then return and S0 to I. So this means you are going to return as lies. So this first word function, what it does is when you have hello world, it is going to return hello. That is the first word of hello world, right? So what it does is initially it starts like traversing, and whenever it sees the first blank space, it will return a slice called and S from 0 to I. 0 to I, where I will be your corresponding location to the blank. I will show an example, or I will do something to get that idea. Okay. So what happens is that I don't see this. We will do some. So in case of a string called hello world, what happens? So this is index 0. Then we have index 1. Then we have index 2. Then we have index 3. Then we have index 4. And then we have index 5. So H E L L and then yeah. So you see that H is at index 0, and this is the index where we will start with, and then E is against 1, and L is against 2, L is against the next L is against 3, and then O is against 4. But in the fifth side we will have a blank. Okay, the fifth index will have a blank. So what happens whenever you see a blank, what we are set to do is to return and S0I. That means you are asked to return this string. Okay, so that will be your first word, right? And as 0 to I means 0 to the values before 5. So if I am going to return like and, right, and s0, let me say right now here I is 5. Okay, so you are going to return the strings, a string with indexes from 0 to index 4. Okay, that will be what you're going to return, because it will only work from 0 to n minus 1 or I minus 1, where I or n is this last value. Okay, so you can only have a string which starts from 0th index and ends at 4th index. The 5th index will not be counted. Okay, so this is what we will return, and it is actually a reference, because as I just mentioned before, slice does not own, but slice is a reference. So you need to return a reference. Okay, and then this is the question. So this is what the function does. It just iterates through it, and then it returns the first word. It's the whole concept that I tried to explain. This is a similar method, but then here the problem is, just try to look at this question. What happens is that we have created a string called s in the main function, and then we are passing it to the first word. Okay, so we are passing it to the first word as a reference. So what it does is it reads and then it returns me hello back. So the word will have hello. Then what we will do is we do s dot clear. Okay, s dot clear means we are clearing this string s. Now then the problem is, what is this word actually point to? The word is actually a reference, right? So this and is pointing to some part of this hello world. So the hello world is present in the heap, and you are pointing to this hello, which is present in the hello world, which is present in heap, right? So you are pointing to that hello, and then you are clearing the entire string. Now, what is this and this word actually pointing to? So now you do not have a pointer and s, because you cannot point it to hello if the hello world is entirely cleared or destroyed, right? So this will throw a compile time error asking for us to get a resolution. I believe you got the topic, but then I'm going to repeat it again. What you do is we have created a string hello world, and then we have passed it to the first word. So to get the first word out of the passed string, okay. But then when we will get a reference to the first word from the entire string that has been passed, what we will do is we will call the s dot clear. The s dot clear function will clear the entire data from the memory. So what happens is it clears the hello world. Now, what is this word or this and s? This is what we return. So we have a pointer to hello. Now, what is this pointer pointing to if we have cleared the hello world entirely? So there is no such existence for such a pointer, and that is why it will give you a compile time. Okay. And these are some core concepts that you need to understand if you're trying to implement memory level problems. But then the problem is you can't just really understand this concept by just hearing it for the first time. You need to go through the Rust book and also try to refer some videos, or obviously, and then to ask us questions, because these concepts are a little bit hard to digest, especially if you are new to programming. Then this is going to be really hard. So I want you to read the Rust book and then also watch some videos as possible, and do ask us questions in the Discord or else in any other form as possible. Okay. And with that, I think we will go to another quiz time. And I think this is our last quiz for today. Yeah, I want you to answer as soon as possible. You'll be given 90 seconds and it is launched. Please attend the questions. Guys, the thumbs up. I'm going to end the poll. Yeah. Share the results with you. Yeah, the first question was which of the following is a slice equivalent to the entire string in the Rust? X is the string. So most of you have answered in different formats. And yeah, so the second option is the right option for in case of Rust. That is, if you pass and X then dot dot, that means you'll like literally give you the entire string. Okay. So in the first option, you'll have from 0 to 2, which you won't give you the right answer. And this one like return till 1, which won't also give you the right answer. But then and X 0 to X dot len, well, that will give you the right answer. Yes. So here like two options have the right answers. Like we will try to figure it out and then give you marks for both of these answers. So this like the last option as well as this second option are both right answers. Okay. And then the next question is slice as ownership over its contents. It's old. Yeah. Well, the answer is false, and most of you have answered it as true. Well, I told you before that slice does not have ownership over the contents it holds. It is actually a reference. What it does is borrowing. Okay. That is why when we returned a slice, you saw that ampersand symbol, right? And symbol. So what we do is what we take a reference. We don't actually own in case of a slice. Okay. Because we cannot own a substring from a string until we take a copy of it. Okay. If you do not take a copy, what you do is we are taking a reference. That is the issue. When you actually delete the entire string, you cannot have a copy here. So that's the entire concept. And then summary of the concept that we have discussed today. So ownership, borrowing, and slices. These are the memory safe features in Rust. And Rust language also gives you control over your memory usage. And as I said before, once you set a value, a particular value to a variable, then it becomes the owner of that value. And if you move that value to another variable, then the value will be passed or moved to the next variable. Okay. Now the next variable becomes the owner of the value. And in case of borrowing, you are actually not owning the value, but then you're taking a reference to this value. Okay. Taking a reference to this value so that reference could be of either two types. It could be mutable or it could be immutable. If you are taking a mutable reference, then it can be used to change the entire value. Okay. And in case of slice does not have ownership. What it does is it returns a reference of some substring or some slice of strings in the main string. Okay. I think you have got a good idea of what I've tried to convey today. But then you have to go through this concept multiple times because this is one of those hard concepts that take some time to digest. Do ask us questions. I surely believe that you will have a lot of questions in mind after this session. Okay, then guys, thank you for bearing with me. We will see to the Q&A right now. Okay. So I don't see any kind of questions right now. So anybody do have doubt, then please do ask. Is Deepak Singh here?
Yeah, hey guys. So I'm also not seeing any more questions, and other questions were answered by Deepak Chaudhary, of course. So first of all, thank you, Rishi, for another amazing session. So guys, technically, Rishin was incorrect when he said that this was the last quiz because, as you all know, there is an overall quiz that we do. But yes, that was actually the last quiz, which was in part of the session, which is kind of a polls that we are trying to do. So, I mean, not such a happy ending for all of you because your knowledge will be tested once again. So what I'll do is I'll just share two links. One of it is basically the link which is going to be of the assignment, right? And the other will be that of the quiz. Let me start with the quiz link. So the quiz will be active for over an hour. Just try to submit the answers as soon as possible. And the assignment link will be active until day after tomorrow, or by 3ish in the afternoon. So try to finish it up before that. Both the links have been shared in the chat box. I hope everybody has received it. And yes, I wish you all the best. Just try to practice as much as possible. And of course, these quizzes and assignments are basically just to make sure that you do a little bit of homework and just get a hang of it, and uh, don't just leave everything for this sessions to cover up, because obviously whatever we are trying to teach here, we're trying to be as comprehensive as possible, but without your own effort, without your own homework, uh, it wouldn't be enough. And I have also shared the Notion link before with you guys. Can you please share the video board link in group? Okay, so we'll do one thing. The leaderboard will share in the Discord CP channel. No worries. Yeah, so guys, I was talking about the Notion link. So what I would also request you all to, next time when you come for the session, which is day after tomorrow, same time. Uh, so on 19th, 7 p.m. will be the next session. Obviously, we'll be communicating the same with you guys on Discord or social media and the WhatsApp groups. So before that, so just a quick reiteration of the fact that try to do self uh, learning of the next session, the next topic. When I say self learning, just try to go and get introduced to the next topics that we are going to discuss. So it will help you get a little bit more context into it. And for all the students who joined us for the first time, make sure you check out the other sessions. The links are updated in the Notion link that I am sharing, that I've shared in the chat box, which was also shared earlier. But in case somebody joined in late, please refer to the link. So all the sessions, all the details of the sessions, and all the YouTube links will be updated over here. Today's YouTube link will be up by tomorrow morning. So if you want to revise, so you can do that tomorrow. Okay, before we end the session, Praveen sir, Deepak Chaudhary, Rishin, any other final comments?
No, I think Deepak, thank you, Rishin. Thank you for a wonderful session. And guys, I think you all are doing a great job by being here. This journey will appear slow when you are into it, but you will never imagine, you will never believe after some time when you be consistent here, what all will you become. So believe me, like I recall Rishin was talking about, and even I talked about on day one, that Rust is going to be one of the most important languages for programming. Keep that in mind. So what you are learning right now is, so important. And of course, you can get the Rust book, Rust lang book, Rust videos everywhere. That's not the point. But what we are trying to do here is to structure it, go in a systematic way, explain you the important concepts, help you understand things with the help of the polls, the questions and the quizzes, and then going over those questions which are, which are difficult for you, explaining you the concept. So I think a lot of effort is going on in between. Believe me, I think what you are seeing right now, this 1.5 hours, 2 hours time, what we are spending with you, it is not the only time. We spend a lot of time in the background to make it effective. A lot of planning and effort goes into, right? So please make the best use of this. And if in fact all these videos are uploaded to the CEP channel of IBC Media, CEP playlist of IBC Media, please go and if required repeat, watch it again. And if you are coming up with questions, please feel free to come next day and ask the faculty here, ask Rishin whether you really have anything that you really did not understand. And one last thing from my side, Deepak, is that once you are spending time on these things, then only you would be able to do a lot of conceptual level work in substrate, which will happen after the Rust sessions are done. Okay, so Rust, again, substrate is another very important thing which will be fundamental to Polkadot. And to be able to do good there, you have to spend very, very quality time right now in Rust. Okay, So with all these things, I definitely want to wish you all the very best and continue learning. Thanks, Deepak.
Absolutely, sir. So a very totally out of syllabus question to all of you, guys. If you have seen the movie John Wick, raise your hand quickly. Like I'll just go through this something, reiterating some point that Praveen sir has said. Raise your hand if you've seen the movie John Wick. Okay, I'm seeing the count increase quickly. 9, 10. Okay, the numbers are increasing. Yes, 12, 14. Okay. Yeah, so you might remember, so in the first movie, when his dog gets killed, and the guy he goes after, and when he's speaking to the father when he's scared, and he says something about John Wick, right? The most scary part about John Wick is that he is the man of focus. So what exactly becomes scary when you are a man or a person or a woman of focus is that everything else becomes secondary. For him, his focus was on what and how he will do whatever. I won't get into the details and spoil the movie for everybody else. But for you, the point of focus has to be what exactly you are gaining out of this exercise, this IBC entire IBC program, right? And the end result has to be that you should be in the next 2 months, you should be able to come up and code and start working on your own project. You should become a developer in the blockchain industry. You go from Rust, then you move on to Substrate, and then become start writing code so that you build your own dApps or DAO or whatever amazing, wonderful things you want to create. So your focus is extremely important, and your hard work will be what the focus and your hard work are the only things that will get you there. So just confirming on the point that Praveen sir was saying, that you have to go and practice and keep doing it to achieve where you want to achieve, and you'll definitely be there. And with obviously the expert guidance of people like Rishi, Deepak Chaudhary, and obviously our very own Praveen sir, uh, will try to make your journey as smooth as possible, provided you are ready to put in the hard. Sorry, Praveen sir, I thought I just got that click in my mind when I heard you, so I just wanted to share that.
No, absolutely. Thanks for sharing that, Deepak.
So, guys, thank you once again. Thank you, Praveen sir. Thank you, Deepak Chaudhary, and obviously our very own Rishin R for a wonderful session, for a wonderful insight into another session on Rust. Obviously, we'll be coming with more. This was the second session on Rust. We have 3 more to go. We'll see you on 19th, 7 p.m. same time. Have a great night. Once again, take some time out and work hard and keep your focus intact. Thank you once again. Thank you, Rajesh, and thank you, Deepak Gudem, for joining the call and keeping us in this call for such a long time and handling everything in the back end so well. Thank you so much, everyone. Have a
Yep.
great night ahead.
And have fun as well. Thank you.
Yes, absolutely, sir. Thank you so much, sir. Thank you all.
Yeah. Bye-bye.
And guys, if there are more questions that you might have, feel free to put it on Discord. We'll address it for you. Thank you. Do we have session tomorrow? No, you don't have a session tomorrow. We'll have it after tomorrow. And the Notion link that I've shared has the dates, so feel free to just check those out.